patent changeable bank lock, or to give it its full name, Hobbs Hart & Company patent treble action transmutation bank lock. Over the course of this video I will partially disassemble this lock in order to give a full explanation of its features and the design elements. Firstly, we'll just cover the key. As you can see, the steps of the key are arranged so they can be removed. By undoing the screw in the end of the bit, all the steps will come out and can be arranged in any order you wish, the screw replaced, and the lock will then set itself to whatever the pattern of the key is that's used to lock it. I'll just briefly show this with the cap on. The function of the detector plate, as it is called on the top, is to prevent the insertion of tools into the key lock as an anti-manipulation feature. Once a key is partially turned, the access to the keyhole is blocked off by the plate, and until the plate is blocking the keyhole, the bolt is blocked at this point. I'll now pause the tape and remove the top plate of the lock. Here the lock is shown with the top plate removed. This piece here is raised and lowered by the curtain and acts on the detector plate above the cap through this pin. The curtain within the lock here serves two functions. Firstly, it is to restrict the movement of any picking tool inserted into the lock, and secondly, through the action of this spring-loaded wiper, it cleans the bottom of the lever bellies with each revolution. This is to prevent an attack that was possible on an earlier version of this lock, where Linus Yale discovered that the lever bellies could be coated with a mixture of lamp black and glue, I believe, which allowed sweep marks to show the pattern of the key. Although that wouldn't be effective on this design, the wiper is still retained. As you can see, a complicated lock. There are effectively three sets of levers. The primary set, the secondary set, which will be more visible when I remove this plate, and the third set. The bolt gate, as it were, is here at the interaction between the secondary set and the third set. The pattern that the lock is set to is recorded here. At the moment the lock is open, so everything is in neutral. This lock contains a number of features to prevent its being picked and decoded. I'll just throw the bolt with the key so you can see how the lock changes when it is set. Now you can see the secondary and third sets of levers are separated, and the pattern of the key is set here. As you can observe, these are at different heights. There are a number of features within this lock to effectively frustrate any attempt to pick it. The first of these is an interlock on the top of the bolt. Here, you can just see the top of it. This is fairly clever. The first thing anyone wishing to pick a lock must do is apply tension. As you can see at the moment, there is absolutely no movement on the bolt, which prevents the gate, being the interlock between the third and the second set of levers, from even being made to touch. In order to defeat the interlock, which is in the shape of a hook there, it is necessary to lift one or more of the levers to a fairly high position, such as that. Now, of course, in doing so, you may have already lifted that particular lever too high, and you would have no way of knowing. Once that lever, or any lever, is lifted, the interlock is raised, and you could now theoretically apply tension, like so. The third set and second set of levers are now touching. However, this lock can still not be picked. There is an anti-pressure device at the bottom of the lock underneath this plate. The only way you can open this lock is for the third set of levers to enter the second set with no torque applied. Any attempt to apply torque at this point will trip this anti-pressure device and effectively prevent the lock from being opened. Even if you were to set these gates to the correct height, with the anti-pressure device engaged, the lock would not open. I will now pause the tape and remove this inner plate.